Hello, everybody. Welcome to another Read Your Genes podcast. So let's jump right in with a few questions that we have. How to read the full genetic report, one versus two. So I think this person is asking, what is the best way to read? So when you get a genetic review from us, you get the full genetic report, which is well over a couple hundred pages. And then you get the genetic summary report, which is around 20 pages. And then you get the genetic action step report, which is just a few pages. So if you want to dig into the full report to see different things, you certainly can. When it shows a one or a two, that means you either have a single allele defect, a one, or a double allele defect, a two. So again, remember, just because you have a two on a gene doesn't mean the gene doesn't work. It just means that there's a good chance that that gene could be hindered in its function. Now, there are a few defects or allele, ones or twos that actually can benefit us as far as health goes. For instance, the dairy gene in the genetic profile. If you have defects, you actually retain the ability to break down lactose. So remember, the dairy genes are not looking at your ability to break down the dairy protein casein, um, nor are the HLA genes with gluten an indication that you for sure have a gluten sensitivity, even if you have twos on there and on the genes for more serious gluten issues. Even if you have twos on there, doesn't mean you definitely are going to have gluten issues. It just means it increases that risk. Now, if you have twos on the dairy genes, it actually means that you retain the ability to break down lactose, and you will probably be able to consume dairy better than if somebody did not have any defects. So if there was no, it was just blank. So it doesn't show a zero if there's no defects. If it's that's called so-called the wild form of the gene, meaning there's no defects on the gene. So there's some defects that actually would give us better lifestyle changes, meaning that now you could maybe eat dairy. At least you'd have the ability to break down the lactose, so you don't might not be lactose intolerant. Now, that being said, with something like dairy, 90% of the people that have issues with dairy, it's not the lactose, it's the casein. They have developed antibodies to the casein, so they have a dairy allergy. There's a difference between a dairy allergy, quote unquote, sensitivity, because you have antibodies to casein, the protein in dairy, versus a lactose inability to break down lactose, meaning you don't make lactase, the enzyme, very well. So, totally different things. But when you read the full report and you're looking at that, some people also get very concerned because a gene family, let's use the PON1 gene family, for instance. That's the PON1 pathway of detoxification, part of your phase 2 detoxification pathway in your liver. Let's say you have, out of that family that is shown on your report, I don't know how many genes are shown, maybe 5 or 10 genes in the PON1 pathway family. Let's say you have twos on 3 of those genes. Well, that doesn't mean that your detox pathways in your liver are completely shot or anything. It just means that you may have more issues with phase 2 pathway, and you might be a slower detoxer as far as your liver detox pathways go. That's what that means. That's why I try to summarize it in the summary report. Otherwise, it gets very confusing. People get very concerned when they look at their genes and they think, oh my gosh, I have a defect on this pathway. That means, I'm, my body is, you know, not going to work correctly. It's so much of your genetics, as you'll see throughout, if you spend some time on the course and look at this, yes, these genes can be important and can affect our life, and you can make some epigenetic changes based upon knowledge of these genes, but don't think that you're doomed because you have genetic defects. So, but that's what the 1 and the 2 means. It does get confusing, and you do need to study a lot to really kind of figure out what these different pathways are. Next question, could you briefly give an overview of the different pathways covered and briefly what they do? Are they all portions from that big chart we see in the videos? I am trying to grasp the big idea. Yes and no. The big chart that you see in the videos is really only a piece of it. So the big chart that you see in the video does not include all the genes. So, but it includes the major ones. So there's more genes than what are shown in that big chart. But that big chart gives you a good kind of overview of some of the major pathways. It'd be really hard to give a brief overview of the different pathways because you're looking at a lot of different pathways. Your genetic report covers hundreds and hundreds and hundreds of genes. So that's why we created the course, and that's why we created all the videos that go along with the course. But the big idea, to grasp that big idea, would be that we're looking at the major metabolic pathways, how your body processes nutrients, how your body gets rid of chemicals, how your body makes enzymes, how your body functions to make energy, to get rid of poisons. That's what the full genetic report is looking at, those genes. Now understand there's other genes that just haven't been well researched that are actually included in what is tested for, but there's just not enough knowledge. So it's not even included in that full report. There's not enough knowledge to give you any data on because there's just so much research that has to go on yet as far as genetics. That's why when we first started doing these genetic reviews, the full genetic report was like 50 pages long. Now it's, what is it, 200 and some pages long? It just keeps getting longer. So as new research comes out, it gives us more data. So then that report is expanded on. So some people have contacted us that have done a genetic review with us like 6, 7, 8 years ago, and they say, should I run my genetics again? Well, the answer is no, but there's a caveat to that. So when we first used to run genetics, we didn't have our own genetic test kit. And we ran 23andMe, and we used that data from 23andMe to put into the report. And that gave us about a 30 to 50 page report. I think when I first started, it was like 28 pages. And then 23andMe actually started truncating their data, meaning that they didn't test for as many genes because they were trying to compete price-wise with Ancestry.com. And they started testing less metabolic genes. So they were testing more ancestral type genes. So we dropped 23andMe. Plus, I didn't trust 23andMe's ability to keep people's data safe. So that was a long time ago. And then we started up with DNA supplementation testing about 4 or 5 years ago. And we're testing many more gene subsets and gene families. So it gave us a bigger picture of a person's health picture. So the report was well over 100 pages. Well, as new data comes in on some of the genes that are tested, but yet don't appear in your full report, the full report gets bigger and bigger and bigger. So if a person did a genetic workup with us back when we were doing 23andMe, then yes, we should run a new, fully new kit, get your saliva sample again, and do a fully new kit because we're testing for, you know, thousands and thousands, tens of thousands of more genes than 23andMe ever tested for. So you're going to get a much more um, healthful, picture of what your overall health is as far as genetics goes. If you did a test with us under the DNA supplementation saliva kit, so maybe you did it 4 years ago, but your report then was only 120 pages, you could ask for a new report because the the genes were tested, but the data wasn't there yet. So as data comes in, as we're constantly adding to that report. That doesn't completely answer this question. Could you give me a big picture of what's going on and what's being tested? We try to separate it out into the most logically understandable way to separate out the genes. There's some genes that the known function kind of crosses a couple different metabolic systems, meaning it's not necessarily digestive, but it might be detoxification, or one gene might affect detox and might affect digestion. So you'll see actually in the full report, a gene like the CTH gene is in a couple different categories. The glutathione gene is in, some of the glutathione genes are in a couple different categories. The glutathione has to do with detoxification, mainly cellular detoxification, but it also affects is functioning in the liver with detoxification. So it's in with the liver detox genes, but it's in with its own category. So it does get complicated because your body's complicated. So it's hard to give a really, a brief summary of that. That's probably the briefest summary that I could give. Hopefully that helped answer the question. But it does, a lot of people get frustrated because they're like, oh my gosh, I don't want to listen to all these videos on these different genes. Um, but there's just no other way to do it because there's just so much education that needs to take place. And there's more new information coming out, on a regular basis. That's why I'm trying to add videos on a fairly regular basis as well. Can I get genetic testing for my family members? When is a good time to consider this? I think we answered this question a few weeks ago. But yes, you can do it on your family members. You really have to wait until a person can spit into a tube. We used to have a cheek swab kit, but they pulled that for a while. They're having some troubles with it. I don't know if that is back up again. If we could do the cheek swabs, that would be for people who can't spit into a tube. So it would be for younger children. Now, again, like I said last week when I answered this, if you had the genetics on the father and the mother, you could kind of extrapolate a little bit what troubles the child is possibly going to have. Because if the mom has a single allele defect and the father has a single allele defect, the child's going to definitely have a defect. If both the mother and the father have double allele defects, the child's going to have a double allele defect in that gene. So if you had genetics on the father and mother, you wouldn't necessarily have to look at each child. Certainly, if one of your children is having issues, you could look at it. Can a child have defects that the parents don't have? The answer is yes, because the child could have acquired defects, not inherited defects. So an acquired defect has to do with something they were exposed to that damaged the gene. So could a vaccine damage cause an acquired defect? Well, possibly. You know, they just won't allow studies on this stuff. In order to do a study, you'd have to, to have a published study, you'd have to get approval through the FDA. They will never approve some sort of study like that would show deleterious effects of vaccines or medications, but that simply is true that those can cause defects. How do you think we got all these defects in the first place? it's really interesting because I've seen people's genetics. I've looked at thousands of people's genetics now, and the older the person is, the cleaner their genes are. It's just, I just looked at a person's genes. This was a couple of weeks ago. We got some sets in, and the person was in their 80s, and I thought, oh my goodness! I actually told one of my staff people, this person's genes are the cleanest I've ever seen, without mentioning their name. But then you see people in their 20s um, with just a lot of defects. So I do believe that it's because of the chemicals in our environment that are affecting us and damaging our genetics. And you know, they're not something that goes away. It's not something that gets corrected. You'll pass it down to your children. It's just kind of sad of what's happening to our environment. Um, but remember again, even if you have a lot of defects, even if you have, on your PON1 genes, use that as an example again, your major detoxification pathway. If you had twos on all the genes in that family, it still doesn't mean that they're not going to work completely. It just means that you're really probably going to be a slow detoxer, and you should make epigenetic changes. Make sure you're not exposed to glyphosate. Make sure you're not exposed to chemical toxins as best as you can. All these things that you do, knowing your genetics, are things that we should do anyhow, you know? So, but when you look at your genetics, it gives you a sense of motivation, I think, at least, to go, holy cow, my glutathione pathway is just horrible. I need to keep taking glutathione, or keep taking precursors to glutathione to help support that. Or my PON pathways are horrible. I gotta keep taking support for that and make sure I'm not eating out very much, because I'm not going to probably get organic, and I'm going to be exposed to a lot of chemicals that I don't want to be exposed to. I'm not going to be eating candy with dyes in it. I'm not going to be eating, it gives you some motivation to stay on track when we have so much pressure to be, to go off of our diet, to go off of, what we know is better for us. Okay, thanks for being on today. Keep your questions coming in, and we'll see you in 2 weeks.